Good evening students, welcome to basic electrical lectures. So far we covered module 1 portions in detail. So just go through the lectures, and after completing module 1 few students requested please do the revision class for module 1. So I am doing that based on their students request. I am doing revision of module 1. See, you have to concentrate in module 1 DC circuit. You are going to lose marks in DC circuit because it depends how you know the concepts very well. So based on that you will get full marks in DC circuits. There is a possibility losing marks only in DC circuit. Okay, so you have to prepare well DC circuits. Give more time for preparing DC circuits in module 1. So in DC circuits, what are the topics we have? Okay, theory topics. What are the theory topics we have in DC circuit? Ohm's law. Okay, Ohm's law. What is Ohm's law? The current flowing through a conductor is directly proportional to the applied voltage between ends of the conductor and inversely proportional to the resistance of the conductor, provided the temperature and other physical conditions remains constant. You must write this last sentence. Temperature constant. You must write that word. Otherwise, they will give 0 marks. Okay, most of the evaluators, if you not written for a Ohm's law temperature is constant, they will give 0 marks. Okay, be careful while writing that Ohm's law statement. You must write constant temperature. Okay, so keep that. That is important point. Next is Kirchhoff laws. So Kirchhoff law have two types: KCL and KVL. So KCL definition is what? The sum of current entering. The sum of current entering is equal to sum of currents outgoing. Okay, is equal to sum of currents outgoing. Understood? Very simple definition. Next up, KVL. KVL definition is what? In any closed circuit, the algebraic sum of all the EMF sources and individual potential drops taken with proper sign convention would add up to 0. Otherwise, you can write like this. In any closed circuit, the algebraic sum of all the EMF sources is equal to the algebraic sum of all potential drops. Algebraic sum of all the potential drops. This is also correct. Okay. So these are the only theory questions you can predict in DC circuit. Rest every topic problems. See, you must concentrate problems on DC circuit. So problems preferably they will ask problems series circuit, parallel, and combination of series and parallel. So while solving problems on series circuit, you must remember the following points. For series circuit, you must remember this concept. Current will be same across each and every element. So then, what is the voltage? The applied voltage to the circuit will be V is equal to V1 plus V2 plus V3 for a series circuit. Then what is the effective resistance in series circuit? Sum of all the resistance, R1 plus R2 plus R3. If it is another resistance, R4. It goes till nth resistor. Okay, remember this only first point when you are analyzing series circuit. Current should be same in all the elements. That is called series circuit. Next, second one is parallel circuit. So parallel circuit. So in parallel circuit, what is the concept? Voltage should be same. Means what? Voltage across each and every element should be same in parallel circuit. And what about current? I is equal to I1 plus I2 plus I3. In parallel circuit, supply current is equal to sum of all the branch currents. Then what about effective resistance? Effective resistance in parallel circuit is 1 whole divided by 1 by first resistor, 1 divided by second resistor, 1 divided by third resistor. So it keep on goes. Okay. If it is nth resistor, 1 by Rn. This is the R effective resistance. See, in parallel circuit, when two resistances are connected in parallel, your effective resistance will be R1 R2 divided by R1 plus R2. Remember this equation when is having only two resistances in parallel. Similarly, when we have more than two resistors are connected in parallel, then remember this equation: 1 by R1 plus 1 by R2 plus 1 by R3. If it is more than three resistors in parallel, more than two resistors in parallel, use this formula. Exactly two resistors in parallel, remember this formula. Numerator multiply the resistance and denominator add the resistance values. See, you must stick on to this first point. Series circuit, current should be same. No matter whether you are able to solve problem or not, in your mind you should fix. Series means current should be same and parallel means voltage should be same. So if you interchange this, you are totally losing marks. Remember, series current should be same, parallel voltage should be same. That's it. So that is important point. So while solving problems, you must know these 2 points majorly. Next, the second, third point is how to find effective resistance. How to find effective resistance. How to find effective resistance. For that, you must remember this concept. Okay. Let's say R1, R2, and R3. So look at here. In order to identify the 2 resistors are connected in series, it should be in this form. So R1 and R2. See, for series circuit, there should not any disturbance for end-to-end connection. Okay. If there is a disturbance, then you cannot say those 2 elements are in series. Now these 2 elements are in series. Now I will write one more resistor here. See, starting and finishing end, starting and finishing end, starting and finishing end, starting end to finishing end of R1 connected to starting end of another resistance. But one more resistor is disturbing for that end-to-end connection. So therefore, you cannot make series combination between R and R2, R1 and R2 in this network. Similarly, R1 and R3 are not in series. They are series if I remove the R2 resistance. See, for end-to-end connection, there should not any disturbance. Then you can say those elements are in series. So in actual network, it is connected. Disturbance is there. So therefore, you cannot make these 2 are in series. Then R2 and R3. Check this. R2 and R3 are in series? No, it is not in series because R1 is disturbing for that end-to-end connection. So now look at here. Now R2 and R3 are in series because there is no disturbance for that end-to-end connection. Okay. Then think about parallel. See, parallel means, so 2 resistors will be there, starting and finishing end, starting and finishing end. Starting end of each resistor connected to one common point, finishing end of each resistor connected to another common point. So it is parallel circuit. See here, starting end, finishing end. Starting end connected to one common point, but finishing end is not connected to anywhere. So therefore, you cannot make these 2 are in parallel. Then similarly, R1 and R3, finishing end is connected to one common point, starting end of this 2 resistors not connected anywhere. So you cannot make parallel combination in any of this combination. So this network is neither series nor parallel network. Remember this concept. Okay. This concept you apply while finding effective resistance for the given circuit. See, all the problems will start from this topic, effective resistance. Later you are applying all these concepts and all. Then next one is, you must pause the video and then copy down if needed. Next, number 4, you must know current division rule. You must know how to apply current division rule. Where I can apply current division rule? Remember, we can apply current division rule only in parallel circuit consisting of 2 resistances only. Okay, look at here. I am writing 2 resistors. Okay, what is current division rule? By knowing supply current, I can find branch currents. 2 resistors are there carrying R1 and R2 resistors. R1 carries I1 current and R2 carries I2 current. And this is the supply current. How to write current division rule? So means I am writing branch currents by knowing the supply current and resistance values. How to write I1? I1 can be written as supply current into other resistance. You are finding current in this branch, you write other resistance. What is other resistance? R2 divided by sum of these 2 resistance, R1 plus R2. Similarly, what is I2? Supply current. You are finding current in this resistor. Supply current into, you write other resistor. What is other resistor? R1 divided by R1 plus R2. This is in case of 2 resistances are connected in parallel. Okay. See, later, after finding all these values, you simply add I1 plus I2 should be equal to I. Now take another example. So let's take 3 resistors, R1, R2 and R3. R1, R2, R3 are connected in parallel. No supply current. So these are the branch currents, I1, I2 and I3. So guys, what is the equation for I1 now? Supply current into you are finding current in this resistance. What are the other resistance? R2 and R3. How they are connected? Parallel. You write that parallel combination. R2 parallel R3. R2 parallel R3. What is missing in this combination? R1 is missing. That you write in denominator. Later whatever written, same thing you copy down here. R2 parallel R3. So what is the equation for I2 in the same way? Supply current into, you are finding current in R2 resistor. What are other resistance? R1 and R3. How they are connected? Parallel. R1 parallel R3. What is missing here? R2 plus R1 parallel R3. See which resistor you are finding current in current division rule, that resistance will come in denominator. Okay. Then similarly for this I3, please help me. Supply current into, yes, R1 parallel R2 divided by what is missing? Which current you are finding? Current in R3 resistance. That resistance will come down. Divided by what I have done here, same thing you write. R1 parallel R2. How to find solution for this? Two resistances are in parallel. Numerator, multiply the resistance value. Denominator, add the resistance value. So this completes current division rule. See, don't go for more than 4 elements. They will give problem. Maximum 3 resistance are in parallel. Okay, fine. The next is voltage division rule. So voltage division rule. So in regular videos I explained in detail. Okay, but for exam point of view, this much is sufficient. So 5 VDR, voltage division rule. Okay. So let's take one example. So 3 resistors are connected in series. Let's say R1, R2 and R3. See, we can apply voltage division rule only for series circuit. So this voltage source drive the current. Current into resistance will get V1. Current into resistance will get V2. Current into resistance will get V3. So by knowing supply voltage and resistance values, I can find all the branch voltage across each and every resistance. That is called voltage division rule. How to write voltage equation? Voltage across R1, supply voltage into right same resistance. R1 divided by sum of all the resistance. R1 plus R2 plus R3. What is V2? Supply voltage into same resistance. What is same resistance? R2 divided by R1 plus R2 plus R3. What is V3? Supply voltage into same resistance divided by R3 divided by R1 plus R2 plus R3. So this is about voltage division rule. See, keep in mind this rule is applicable only for series circuit. Now look at here. I will add one more resistance here. Okay, R4. Now these two are connected in parallel. R3 and R4 are in parallel. If I take effective of that resistance, we will get one resistance. Now that resistance, this and this are become series. But actual circuit is what? Series parallel combination. I converted this parallel combination into one element. Then overall it looks like series circuit. Then you can apply voltage division rule. Now we can write voltage equation. V1 can be written as supply voltage into same resistance divided by R1 plus R2 plus open bracket. You should write R3 parallel R4. Okay. What it happens? It becomes one resistance. Now all are connected in series. Got it? So this becomes R3 parallel R4. Numerator R3 parallel R4. What is voltage across R3? R3 and R4 is same because parallel voltage will be same. So V3 can be written as supply voltage into R3 parallel R4 divided by R1 plus R2 plus R3 parallel R4. Okay, got it? So you must know all this concept, then only you can solve problems on DC circuits. Okay. So along with this current division rule and voltage division rule, you can solve problems in a confident manner. Next part is power equations. So power is equal to voltage into current, power is equal to I square R, and power is equal to V square by R. So you must know this relation. So this will be very kindly helpful while solving problems, because they can give data in any manner. So all the problems can easily solve if you know all these 5 concepts in depth. So in my regular video lectures, if you want to revise module 1 is, please revise those 5 lectures. Class number 1, 2, 3, 4. You watch that, so till you get clear cutting concept. Same thing I am going to apply. That we can take one problem. So how to apply all this concept on one particular problem. Okay, how we can apply voltage division, how we can write current division rule, everything we can go through this problem. See, now look at here. So let's take 15 ohm resistance, and this is okay 20 ohm resistance, 30 ohm resistance. Current flowing here is 1.8 ampere, and this is 15 ohm resistance. Is connected across the supply voltage V. So my question is, they are asking questions: find supply voltage, find supply current, find current in all the resistors, find voltage across this resistor, this resistor, this resistor, like that they will ask. See now, what is the hint given? So voltage is not given. How can I find current? Don't think like that. You observe the circuit. What they given? These two are in parallel. This combination series with this. Okay. Supply current flows here till here. you will get same current. After that, current divides in these two branches. That current they given. Okay. Now current into resistance is what? Voltage. So 20 into 1.8, you will get 36 volt. Parallel na, 20 and 30 are in parallel. Whatever voltage here, same voltage will be here. So 36 voltage. That voltage by resistance, you will get current. How much current you will get? 1.2 ampere current you will get. Now some current flows here. That current get divided into these two branches. Once I know the branch currents, add this branch current, you will get supply current. 1.8 plus 1.2, you will get 3 ampere. Same current flows here. Then what is the voltage across this resistor? Okay, 15 is how much? 45 volts. Now this voltage and this combination, okay, if I make effective, we will get one resistance. That and this all in series. In series, we can add the voltage. What is voltage connected across the circuit? 45 plus this voltage is voltage connected across the circuit. 45 plus 36 is how much? 81 volts. See, problem completed. I find voltage across all the resistance and I find current in all the resistance and voltage across the network also. What are other things? You can calculate power in 15 ohm resistance. What is power formula? Voltage into current. I am finding power in only 15 ohm resistance. What is voltage in 15 ohm resistance? 45. What is current in that? 3. 45 3 is how much? 135 watts. Over. The next one. What is power in 20 ohm resistance? Okay, that is you can write V into I. So power is equal to V. Which resistor you are finding power? In 20 ohm resistance. You take voltage across that 20 ohm resistance. What is the voltage? 36. What is the current in that resistor? 1.8. So you will get some amount of watt. That you can write it later. Next, because it is fractions, I can't write directly. Next, what is power in 30 ohm resistance? So voltage into current. You can write any formula, V square R or V square by R or I square R, you will get same answer, all this. Next, power in 30 ohm resistance. What is voltage in 30 ohm resistance? 36. What is current in that resistor? Okay, 1.2. You will get something. So there will be a power will be around this will be around 63.8 and this will be around 43.2. Okay, it may come like this. That you can do it because same problem I done in regular videos. Okay, just go through that. If any small silly mistakes, need not worry. What is the total power now? Voltage into current. I am finding total power. Means you take total voltage how much? 81. What is the total current? 3. 81 3 is how much? 243. By adding all this, you should get 243. So therefore, one concept, total power dissipated in circuit is equal to sum of the power dissipated in each and every resistor. Remember this concept. So most of the problems you can solve by remembering this concept. Total power dissipated in a circuit, whether it is series circuit or parallel or combination of both, the total power dissipated in a circuit is sum of the power dissipated in each and every resistor. Okay, got it? So this much is sufficient to get confident to solve problems on DC circuits. So next is Kirchhoff laws. You can go through that. Go through the rules of Kirchhoff law. Whenever current enters the resistors, mark positive. So KVL rules. You remember the KVL rules. That is more than sufficient. So for a resistor, whenever current enters, you mark positive, leaves negative. Okay. Now for this fixed polarity, how this current flows? Due to some assumed direction. Now for this fixed polarity of the resistor, if the current flows from plus to minus, then you write drop. Drop is written as minus IR. Next, for the same terminals plus and minus, if the current flows in this direction from minus to plus, then you should write rise. Voltage rise is written as plus IR because resistor is a bidirectional element. It can receive current in either direction. So next, another part we have in a while solving problems on EMF, so Kirchhoff laws is we have common thing is EMF source. The polarity of EMF source, bigger one is plus, smaller one is negative. That indicates anode and cathode plates of a battery. This EMF source also can receive current in either direction. When a current flows for this EMF source from plus to minus, you should write minus V. That indicates load. Okay. So then similarly for a EMF source, okay. So if the current is flowing from minus to plus, then you should write plus E. Then you should write plus E. This is the rule you must remember. Okay. So then another way is finding current in all the resistance. They will ask what is current flowing in each and every resistance. We can take typical network. So from that we can easily understand how to find current in all the resistances. So one resistor is here, one resistor is here, and one voltage source, resistor, one more resistor, and another one voltage source, resistor. Like this we can write. Let's take R1, R2, R3, R4, R5, R6, okay, R7, okay, E1, and this is E2, and this is E3. Let us assume it is having 3 loops. This one carry I1 current, this will carry I2 current, and this will carry I3 current. Okay. Okay. Now look at here. What is current flowing in this resistor? I1 only. I1 only. What is current flowing in R2? See, now this R2 resistor is placed between 2 loops, loop 1 and loop 2. So the current flowing through R2, resistor is I1 minus I2. Look at here. This current is entering to the resistor, mark plus and minus. This current is entering this resistor, mark plus, leaves minus. Polarities are different. Means you should write subtraction. Means the both loop currents. This current is coming like this. This current is coming like this. Both loop currents are facing opposite to each other. Then you should write subtraction. What is current in this resistor? I1 minus I2. What is current in R3? I1 only. Same current return back. Same circuit circulate in this loop. But this resistor lies between 2 loops. So those 2 currents will affect on that resistor. What is current in R4? I2 only. What is current in R6? I2 only. What is current in R5? See, this current is coming like this. Okay, this current is coming like this. This current is going like this. Both are facing opposite to each other. So what is the current in R5 resistor? I2 minus I3. Okay, what is current in R2? What is current in R2 resistor? I3 only. Okay, and based on the polarities, you can get 3 simultaneous equations, 3 loops, 3 simultaneous equations. By solving simultaneous equations, you will get I1, I2 and I3. Later they will ask determine the branch currents. So these are all the branch currents. You must find current in each and every resistor. That is called branch currents. Understood, guys? Okay, fine. So next is, see, if any resistor placed between 2 loops, if the currents are facing opposite to each other, write subtraction. If the currents are coming in the same direction for that middle resistor, then you take positive sign. So refer the concept in regular videos. That is class number 8. Class number 8 or 7. Okay, that you can go through that. So this completes DC circuit. Now AC fundamentals. In AC fundamentals, you must concentrate more on derivations. Okay. Before starting derivations, you must think on definitions. So definitions, pakka one question will come on definitions. So what are the definitions? Define frequency, define time period, and define maximum value. Okay, define maximum value, define peak to peak value, define peak to peak value. Okay, then define instantaneous value, and define form factor. Define crust factor. Form factor is Kf, crust factor is Kp. Okay, then define RMS value, define average value. So define cycle, define angular frequency. Like that, 10 to 12 definitions will be there. You must study all the definitions. Okay, later, next second part is derivations. Okay, derivations. What are the derivations? Okay, RMS value derivation. Okay, for pure sinusoidal waveform is how much we get if I derive this? Im by root 2. Okay, what is average value for the sinusoidal waveform? We get 2 Im by pi. Go through the derivations. Then RMS value. Okay, RMS current for full rectified waveform, same thing, Im by root 2. And average value for full rectified waveform is 2 Im by pi. Next is, okay, RMS value, okay, for all rectified waveform. So what is the formula for that? Im by 2. Okay, what is average current for all rectified waveform? Im by pi. Im by pi. So you must remember all these equations. Okay, whenever you are finding RMS value for pure sinusoidal waveform, you take integral limits 0 to 2 pi and 1 by 2 pi. That's it. Okay. RMS, no, you must write root. Don't forget to write root. Okay, got it? Next, full rectified waveform, you must take limits 1 by pi integral 0 to pi. Take square root. Okay. And you must write here Im square sin square omega t into dt. And here also Im square sin square omega t into dt. But when you are finding average value, when you are finding average current, you don't write root and don't write Im square sin square. So for average value for full sinusoidal waveform, 1 upon 2 pi integral 0 to 2 pi. So you must take only half cycle when you are finding RMS value for pure sinusoidal waveform, because the waveform is symmetric. It is having equal set of positive and negative values. If the waveform is unsymmetric, means the positive magnitude and negative magnitude are different, then you take full cycle to compute average value. Since it is symmetric, you have to consider only half cycle. Okay. So 1 by pi Im sin omega t into d omega t. So average value for pure sinusoidal. Full rectified waveform also it takes same formula. Okay. Then for finding RMS value, okay, RMS and average value for half rectified waveform. So for half rectified waveform, you must take overall limit 0 to 2 pi, but integrate only 0 to pi, because waveform is present only from 0 to pi. But time period is the same, waveform repeats after every 2 pi radians. Okay, got it? If it is RMS, you must write square root, then you write Im square sin square omega t into dt. Then similarly, what about average current? You must take total time period 1 by 2 pi 0 to pi. Okay. Im sin omega t into d omega t. Rest everything is basics. Whatever you learned in plus 2, apply the mathematical concept. So you will get final answer like this. Im by root 2 for RMS sine waveform, and Im by 2 for half rectified, and IRMS is equal to Im by root 2 for full rectified waveform. So I given a table, just go through the table. Okay. So this is about one part. Next is, after this they will ask simple problems. Okay. So find the instantaneous value at given time. So just go to the problems whatever I explained in the video. Okay. So next is phasor representation of alternating quantity. This is a theoretical topic. You must study phasor representation of alternating quantity. That is two types of phases, three types of phases: zero phase, positive phase, and negative phase. Zero phase means when t is equal to 0, when t equals to 0, your quantity will be, instantaneous value will be 0, that is zero phase. What is positive phase? When t is equal to 0, the instantaneous value is having positive value, that is called positive phase. When t is equal to 0, the instantaneous value will be negative. The instantaneous value will be negative. The instantaneous value will be negative when t is equal to 0, that is called negative phase. What do you mean by phase difference? We need to take two quantities. So this is voltage, and what about current? The current follows the voltage. This is what? Zero phase difference. Okay. Sorry. See now, this is the voltage. For lagging phase difference, so you must write like this. Okay. So this is for lagging phase difference. And next, leading phase difference, I am writing in red color. Voltage will be same. So leading phase difference, you must write like this. Okay, this is for leading phase difference. Understood? So very much important, all these things. And later the last problems, instantaneous value, so all those things. Along with this, the important thing is generation of sine voltage. Okay, generation of sinusoidal voltage. See, this question is very important compared to phasor representation of alternating quantities. So phasor representation is very easy. So generation of sinusoidal voltage is very important. So overall summary, you practice more problems on DC circuit. Means practice in the sense, you just check it whether you know the concepts or not. Are you able to apply current division rule, voltage division rule for a particular problem? That you give a check. Okay. Once you are done, means 100% you understood the concept. Okay. So you should check all the concept, write your one problem, apply the concept whatever you learned. Then like that you should understand the topics. Okay. Next, this is a major part. in AC fundamentals, of course you have to practice derivations. Go through the derivation logic. Don't write, while practicing, don't write entire derivation. What is starting step? Don't practice each and every simplifications and all. Okay, practice only what is logic in the derivation. What is the starting point, and simplifications and all, it should be done by yourself. Okay, it is natural since you done so many, lifelong you are doing simplifications. Okay, fine, got it. And after this you just concentrate on simple problems. Okay, simple problems on AC fundamentals. Okay, they will ask for a given time what is instantaneous current. Okay, if the current is that much, at what time that current comes. Okay, and define frequency, define maximum value, peak to peak value, RMS value, average value, everything, whatever you applied studying in derivation, same formulas you should apply it. Okay, got it guys? So give more weightage to problems in module 1. Okay guys, have a nice day, take care. So please subscribe my channel and please give a like to this revision class.